All right, piecewise functions. Oh, I knew we had to get to these at some point. So for each real number a, the absolute value a is the distance between 0 and a on a number line is denoted by the absolute value of an a. So we have to solve this. So what numbers can go here to make this statement true? We could have the solution set of a -6 or a 6. Okay, so I put -6 in there, it comes out as positive, and that goes in as a positive, comes out as a positive. So now we have to look at this and say, hey, what can we put in here that gives us 4 as an outcome? So this right here has to equal a -4 or a +4, no matter how we look at it. So if I put a 9 here, so a solution set could be a 9, because 9 minus 5 gives me the 4. But I can also put in a 1, because if I put a 1 here, 1 minus 5 is a -4, and -4 comes out as a 4 anyways. So my solution set for those could be a 9 or a 1. Then when we start to look at this one, we try to figure out how to get a -10. So this whole piece right here has to be has to turn out to a 5, but or a -5, but we all know that with an absolute value, because 2 times a -5 is a -10, because the outside number is positive, is an absolute value ever going to be negative when it's inside? And that is no. So there is no solutions here. So this is kind of like a tricky piece. All right, so now we're moving down here, and we have to determine at least 5 solutions that makes this true. So the solutions are like, we can just put them in the brackets, and we can put them together in grouping symbols. 5 sets. So if I put, I don't know, let's put a 0 here. If we put a 0 here, we get 0, right? 0, absolute value of 0 makes y 0. So let's say we put in, I don't know, put in a 1. And we want to make sure some of the numbers are negative. So I put in a 1, absolute value of a 1 is a 1. I'm put in a 2. If I put a 2, again, absolute value is going to be a 2. So now let's throw in a -2. If I put a -2 in there, I'm still going to get an outcome of a 2. If I put a -1 in here, -1 for my x, the absolute value of -1 is a 1. So these are the outcomes. So some kids do this. We have an x and a y. So in this case, I used 0, 1, 2, -1, -2. And if I put a 0 in, I got 0. If I put in a 1, I got 1. If I put a 2 in, I got 2. If I put a -1 in, I still got 1. And if I put a -2, I got 2. So really, it looks like this, but we write it as solutions. So they would have to be coordinate pairs, just in case we had to graph this, which I think we are graphing it soon. So now we have this. So this is like, hey, what can we put in for the x to come out with some y's? So at first, you might not be able to just visualize what you're going to put in for the pairs, okay? And let me move this down because they want 5. All right, so I don't know. Let's just pick, it doesn't matter. Let's put the -1. If I put a -1 here, -1 and a -5 make a -6, but the absolute value of a -6 is a 6. If I put a 0, my x, 0 minus 5 is a -5, -5 and an absolute value comes out as a 5. What if I put in a 1? So if I put in a 1, 1 take away 5 is a -4, absolute value of -4 is +4. Let's put in a 5. 5 minus 5 is 0, absolute value of 0 is a 0. And I don't know, let's put in a 6. 6 minus 5 is 1, absolute value of 1 is a 1. So those are our points. If we needed to plot those, we could. Okay. So let's look at the next piece, this one. So this one is, so these we can put into the calculator, which I'm going to show you in a minute how to do. This one's not a calculator thing, because see how it says x equals, and in the graphing calculator they have y equals. But really, this is going to be just a reflection, and I'll show you how that is. So this is where a chart might come in handy for us. So we're right now, when we make this, we can look at it in a different sense. Let's look at it as, let's do our y's first, like what we're putting in here. So I don't know, let's put 1, let's try a -1, let's try a 0, a 2, and a -2. Okay, so if I put a 1 here, I get a 1. If I put a -1 here, I get a 1. If I put a 0, I get a 0. If I put a 2, I get a 2. If I put a -2, I get a +2 because it's absolute value. Okay, so now in a minute, we're going to graph what these look like, and I'm going to show you how that is done on a calculator. So I'm going to move the paper, and I'm going to move this down, and I'm going to show you how you put it in. Okay, so I'm going to put this next to it so you can see it happening on the screen next to it. All right, so first thing you have to do is be in the y equals button. All right, you got to make sure your stuff's cleared out. Now, see how we have absolute value? There's a process to get absolute value. Okay, so on the graphing calculator, there's a button called Math. Then go over to the word num, and you'll see the very top line says abs. We're going to press enter. Now you've got absolute value bars. Now all we have to do is stick an X in it, which is our typical X button. But see how we're still inside it? We have to get out of the bars. Okay, very important that we get out of the bars. And now we can go to graph. And this is what it's going to look like. Okay, I don't know if you can see that. I don't know. I probably don't get a good view on that. I'll find an angle here for you guys. I don't know. I'm going to get an angle on that. I'm trying. There we go. That's what it's going to look like. Okay, but the easiest way to get to see how you plot it is we can plot it from the points that we were given above, or you can go to second function graph, and you're given the table. Okay, now for some reason we've got a bad glare on this. I don't know. We got 2 lines. Oh, because it's in blue. All right. Well, anyways, if you were to look on your screen, there's going to be an X column, and this column right here is a Y column. And then you can just arrow down to where you want. But really, we can just take from the above points that you did, and we can go 0, 0. We got 1, 1. We got 2, 2. And we got -1, -2, up 2. And we got -1, 1. Okay, so then we've got this vector going like this. Okay, and like we showed on the graph before, I think we saw it way up here, like that. See how it just goes off the graph? It's the same thing that I just drew. Okay, so we have our little vector. Now, there's no arrow tips on the end of a vector. You can just go, and then you can just get as many points as you want. You can grab them off. You will see your X, Y, your second function table way better than I do. Okay, you can only see the 0 here it's the blue writing on that. All right, so now we're going to go to the one next to it. Okay, so now I'm going to go to this. I'm going to go to clear. I'm going to go to Y equals, and I'm going to get that out. Okay, so I'm going to get that out of there. I don't like how the glare is on this. Let me see. Now, it says that, so we're going to go to math again. I'm going to go to num, absolute value, and inside these, I'm going to put an X minus a 5, and I'm going to get out. Then I'm pressing graph. This time my vector looks like this. Let me see if I can get it good. There, that's our vector this time. And if I go to second function graph, see, there's my numbers. I'm going to have 2 columns of numbers, okay? They're very blurry, but if you're using the graphing calculator in front of you, you'll be able to see your numbers. And then you start plotting this, okay? So the thing is, to see this -5, how you read that and understand that is even the graph is shifted from where it was in the middle. It's going to be shifted over 5, but you would think that it's shifting left 5, but really it's the opposite in absolute value. So when we go to graph what we have our 0, 5, our 1, 1, 2, 3, 4, our 1, 2, 1, 2, 3, our 1, 2, 3, 1, 2, and then we have our negative 1, 6, and then we have to get some ones farther down. So we have our 5, 0. I'm just plotting some. 6, 1. We have 4, 1. 6, 1. 7, 2. 8, 3. You can kind of get the idea. So now we have our vector on this one. Okay. And now notice it's the same thing. We just added 5 jumps to the right. So this looks like it would be left because it's negative, but you really, if it's inside the absolute value, you go the other way. So it's 5 jumps right when it's a negative inside. Okay, so that's the plotting of the first two. Okay, now that third one's on a different flip page. These are all notes that you guys are going to be taking. So now, remember how I said we can't really graph this one on a calculator? But this is kind of an easy one to do. We can just do it by little kid stuff. Like we have our plots we did before. So we can do a little XY table. And we can just start picking some. So like maybe -3, -2, -1, 0, 1, 2, 3. And if I put a -3 into an absolute value, it's going to come out 3, put it in, get a 2, put it in, get a 1, get a 0, get a 1, get a 2, get a 3. So when we go to plot this, you're going to see why it's not going to be our traditional vector going up. It's not going to be our vector going down. Since we have an x equals and everything ends up positive with x's, our vector is actually going to be facing like that. So we go over to the positive 1, 2, 3. Oh, these are very small. 1, 2, 3, down 1, 2, 3. Over 1, 2, down 1, 2. We have 0, 0. 1, -1. And then we have 1, 1. 2, 2. 3, 3. And our vector is doing this thing. Okay, so our vector is going that way and that. So that's how that one would particularly look. Okay, now we can do all this kinds of piecewise functions, and we can put stuff in our calculator, and sometimes we only have certain points we go to. So we might have something, we're ignoring this right now. I'm just showing you something. On your homework, you're going to have something like f of x equals absolute value of x plus 3. And then it says -5 is less than or equal to x, which is less than or equal to 3. And that means you're only putting x values or looking at your calculator in that table from -5, -4, -3, -2, -1, 0, 1, 2, and 3. And yes, you would have to plot them all because it's a range. They gave you a range for the domain. They gave you a specific domain. So they gave you specific ones. So you see how, remember, I extended these lines? You would not. Okay, now another kicker is see how these are less than or equal to. Remember when we graphed them, we have to make sure our endpoint, our -5, has a solid dot, and our positive 3 also has a solid dot. So if it ended here, it'd be like boom, and if it ended way up here, it'd be boom. You have to put the dots where they end, okay? And you only do the ones that they're specifically asking you to go from. Now you will be plotting one that has difference. So obviously if it's one of these signs, you have an open circle on it. So just be careful. My answer key will help you out tomorrow when you're done your homework. And as always, I love math. Diet Coke and CrossFit. Oh, I miss CrossFit. Still drinking my Diet Coke, but surgery is tough.